Stefan or Piper or Jacob Vance? He's coming? Okay. All right, so I probably don't need to go over a whole lot. This is going to work the same way that the last semester worked. Same textbook. Oh, Jacob's here. Same textbook as last time. I've got all my information here. Office hours are Tuesday and Thursday mornings before class. Same deal with the calculators. It's just like a continuation of topics from before. Some topics we're going to revisit. Like you'll notice we're starting out by revisiting some factoring and algebraic fractions because that stuff's kind of hard and it's also kind of important and foundational. It's been 4 weeks, so it's like never having seen it before. We have a recitation. This class is a little bit different. There's just 1 hour of recitation each week. And so I'm just going to use it primarily for like practice quiz purposes. There's no recitation the first week, so they'll start next week because next week is when we have our first quiz. We'll have quizzes on Thursdays. When is our recitation?
11.
Wait, when?
It's 11.
Oh, okay, good, perfect. All right, so we'll have it next Tuesday. Will be our first recitation after class, and we'll have a practice quiz ready. So I encourage everybody to come to recitation next week. Starting in the third week, it'll be required if your average is below 75%, and just get in the habit of checking your average on Canvas. Okay. Same deal with the practice exercises. Oh, I don't know what just happened here, but my stylus is not. It's not even Monday. Okay. Well, give me a minute here. All right, so now I think we can come back. All right. So yeah, same deal. Practice exercises are not collected, but please do them. I think by now we know that they will help us do better on assessments. Same kind of organization with problem sets and tests. So you have a problem set to accompany each test. Same weighting of the grades. The drop-in help sessions this semester are Wednesday from 12:30 to 2 and Thursday from 1 to 2 in room 212. I'm doing the Wednesday ones. Linda Wise is doing the Thursday ones for now. I'll take them over probably later in the semester. And then, of course, you can also request like individual tutoring or one-on-one tutoring. Please take a minute to read the academic integrity standards. In fact, what's that? Yeah, there's like a little quiz, like a survey or whatever. So you want to make sure that you read through those and sign. It's the same rules, right? So, I mean, I think we're all pretty familiar with how it works. If you have questions, if you need any clarification, I'm happy to provide that. Maybe now's a good time to remind us all to put our phones on, like, do not disturb or, turn them off or something. And if you require any accommodations, just let me know. You can, you probably already, it's the spring semester, so you probably already have it documented with the Center for Academic Success, but they'll just send me that letter again. And then, of course, I use Canvas extensively. Right now, the home page is set to the syllabus. Probably later today or tomorrow, I'm going to switch the home page to be the modules, which is kind of how it was last time. And the organization's the same. There's going to be a page for each day that we meet, and it'll list what we're doing, and then there'll be our notes, and the video will usually be posted by the next day because that takes a little while. So most of the time, people just turn in stuff, by hand. Like if there's a problem set or like a take-home quiz or whatever. If you want to turn them in online for any of those, that's okay. I've posted like just some guidelines for submitting them online because sometimes I still get like image files, or like somebody that used an app to sort of scan, but it just looks like a photo that was converted to PDF, which just is really hard for me to use. So I've got like a little example of each. So here's an example of a PDF that was just a photo converted to PDF, and it shows up great on the screen. But like if I had to print that out, it's just a page covered in toner, and it's really hard to like make comments on. But I used the same image. I didn't even take a different image. I just ran it through a different filter and cam scanner, and it produced this, and that's really nice and clear and prints out nicely. So. Okay. Does anybody want to go over like how your work is graded again, or are we feeling pretty comfortable and familiar that nothing's changed? Okay. Okay. Then please, at some point this week, read that academic integrity standards document and make sure you sign the contract in Canvas.
Do you see what time it's submitted?
What's that?
Do you see the time that it was submitted?
Do I see the time? Probably.
Okay.
Pretty sure, yeah.
Oh, you just did it now?
Yeah.
So I'm going to see that you did it before reading it?
I read it.
Oh, you read it. Oh, okay. Good. You just like read it right now.
I read it.
He remembers the whole thing from last semester.
Yeah. I mean, that's fair. Like, it hasn't
Honestly, I read
changed.
that one as well.
I think the only thing that's different is that it says MAT-1312 instead of MAT-1311. I think everything else is identical in that document. Does anybody have any questions they'd like to ask?
Why is the projector sideways?
I don't know. Like, somebody who's tall has to fix it. It's
Yeah, Jake could see it.
it's a little janky.
Just do the high school way and put like a pencil under it.
So we begin just doing a little review of what we did before, of what we did toward the end of the last semester, just because it's pretty foundational, it's pretty important. Is anybody here planning to take calculus? It's okay if you're not, but if it's something that you think you might do. Really?
Yes, Stefan.
Probably not.
What?
Stefan just walked by.
Oh, okay. What if I said it's a great course and I teach it and we have fun?
Is it
Then
on-
would you plan to
Is
take it?
on my course
Is that
then?
hard?
Can I take it for free?
Is it free?
Is it?
Well,
Does it count as
it
a
might, if
grade?
it satisfies a requirement, you might need to spend the money anyway.
I was gonna say, like, what if we don't have any
Make it free.
requirements?
You might have like elective
What
requirements.
if I don't have any of those either?
You know what?
You know.
You just hold on.
Wait, does it count as a math credit?
Nobody's gonna like, it's a really great course and, okay, well, whatever. Look, if you want to take calculus because it's enjoyable, I'll just say like, this stuff is useful anyway, but in calculus, one of the reasons people sometimes struggle in calculus is just because they're struggling a bit with the algebra. So they're trying to like bone up on the algebra at the same time while they're trying to like learn the calculus concepts, and it is pretty fun. I mean, I'm gonna put in a plug for that course. It's pretty nice. All right, so this stuff. I mean, you guys could probably help lead this part of the course. You all did this just a month or so ago, right? 6 weeks maybe. So we're going to start factoring. Let's start with part A over there on the left. What can we do? Take out a 2. Yeah, there's a common factor. So we're going to take it out. And then what goes inside?
3x plus 7y. Here.
Yeah. Great. How about the next one?
We take out 3a cubed x squared.
3a cubed x squared. Can you explain why it's an a cubed and not an a to the 5th or an a squared or?
Because a cubed is the highest that any of the variables do.
Yeah, well, I mean, it's the highest one in common, right? Like, 8 to the 5th is higher, but,
It's the most you can take out of all.
yeah, you'd have to pick the least exponent of all of them. Yep, and the same goes with that x squared. So then what goes inside?
2a squared minus 3x plus 1.
Nice, good. Are there questions on any of these? Let's keep going. All right, so difference of squares, always factors in that way. How do we factor the expression in part A? What can we do?
Could you take out a 2?
Yeah. In fact, if you're going to factor, usually the first thing I look for is a common factor. So take out a 2, what goes inside?
It's going to be x squared minus 36.
Yeah. Now what?
So that breaks down into x plus 6x minus.
Yeah, now that's a difference of squares. So there was a difference of squares sort of hiding in the original expression that didn't really reveal itself until we took out that 2. And as Alex says, that's x plus 6x minus 6. Great. How about the next one?
You have to factor, so it's going to be x squared plus y squared.
Yeah, so x squared plus y squared, and then...
And then the same thing with the minus sign.
Mm-hmm. Yeah, because x to the 4th and y to the 4th, they're squares of x squared and y squared respectively. In fact, any even exponent will be a square, right? Just cut the exponent in half, a square. That's what it's a square of. Now what?
You're going to do x plus y, x plus y.
Say that again.
You have to factor each of those again.
Well, so the first one, this one doesn't factor. The sum of squares doesn't factor.
Okay.
So that will stay as it is. But then this is a difference of squares, so we could factor that one again.
Would be x plus y, x minus y.
Mm-hmm. Yeah, great. And so in both of these, we're sort of noticing, again, probably because we've talked about this before, but when it says factor, it always means factor all the way. So after you've made a factoring step, just stop and look at it and see if any parts of it will factor more. Questions before we do more? Okay. Let's factor some trinomials. We're going to unfoil these. So when you factor a trinomial, right, it always starts with, if it's going to factor in this way. Oh, Stefan, hold on.
Glad you made it, Stefan.
It starts with opening up a set of parentheses. How does this work? Does anybody know how it factors?
Is it going to be x plus 5, x plus 2?
Yeah, can you explain how you chose these?
So x times x is x squared.
Mhm.
X times 2, which is 2x, and then 5 times x, which is 7x, And then 5 times 2, which is 10.
Yeah, so we know we need the first two, right, to give us the x squared when they multiply. We know that the last two have to multiply out to this positive 10, and of course, there's two ways for that to happen. It could be 5 and 2 or 2 and 1, and the trick is getting the outside-inside terms to add up to that middle term in there. That's usually like what we spend the most time on, is trying to get that middle term to work out. All right, let's do another one. This one's harder, just because, or I think it's harder anyway. This one's a little bit harder just because that it's not a monic polynomial. That leading coefficient isn't 1. So there's a couple ways we could get 8 to 8, right? It could be 1 and 8 or 2 and 4. The 3 is prime, so that's nice, right? There's only one way to get to 3. And then usually, for me anyway, this takes a little trial and error. Anybody got it?
4x plus 1
Okay, so we have, so that's the 8x squared, and the 3 work out just fine. So then this is plus 2x plus 12x, which gives us plus 14x, and that works out. Nice. More? Oh yeah.
Like you need to ask.
What?
Like you need to ask.
I like to ask, I like to ask questions because I know that you guys are very eager to do more. So like the enthusiastic response I get is worth the effort I put out in asking the question. Factoring by grouping. So with this, factoring by grouping is usually just sort of like a way to kind of organize your terms so that you see a common factor kind of reveal itself when there otherwise might not appear to be one. And with this first one, they've done some of the work for us, right? We could see a common factor already because they did some of the grouping and some of the factoring already. So we have this common factor of x minus 1, and we could take that out. What goes in these parentheses now?
H minus 2.
Yeah, h minus 2. We just take these guys to put in there. So in that one, they did some of the work for us. Here, they haven't done any of the factoring for us, but we'll note that there's no common factor for all 4 terms. But if I kind of look at this group as a group separate, and this as a group separate. So that first group, what could we do with those terms?
Take out 3.
3, and then what goes inside?
X minus 1.
Mm-hmm. And then plus, what do we do in the next one?
Take out an
Yep. And what goes inside?
X minus 1.
X minus y. So now now we have a common factor that's revealing itself to us. What's the next step? What do we end up with?
3 plus a and x minus
3 plus a times x minus y. Yeah. Are there questions? Does anybody want to discuss how we got from here to here? Okay. Now this next one, I'm gonna tell you a personal story. I used to not like the sum or difference of cubes. I would just get annoyed when I have to do it. Now it's one of my favorites. That's it. It was a really short personal story.
So inspiration.
I just really like it because it's like such a clear pattern.
Much
Like-
inspiration. Such wow.
What's that?
It's a much inspiration. Such
Yeah,
wow.
yeah. So, right, so the way these work, right, is you just your first factor is you just remove the cubes, right, but you keep the sign. So x cubed plus y cubed, your first factor, the little factor, x plus y. And then the big factor, we have 3 terms, each of which we get by multiplying 2 things. X times x, one of each, x times y, and then y times y. Pretty like set pattern on how we get those. When you compare both of these, it always ends, the big factor always ends in a plus. And the middle term of the big factor, that sign always differs from the sign. And so when it's a sum of cubes, it's a minus x times y in the middle. And when it's a difference of cubes, it's a plus x times y in the middle. Let's factor this. So I'll say, like, factoring a difference or sum of cubes, the first step is just recognizing it as a difference or sum of cubes. So this is 2 cubed plus, and then 3x in parentheses cubed. That might help to see it that way first. Where do we go from here?
So where you like multiplying like the 2 times?
Well, I mean, so this is a sum of cubes, right? So I guess I just want to see if can we use this.
We should get a 2 plus 3x.
Yeah, so we have the little factor, 2 plus 3x, and then the big factor. I think that big factor is what you were just talking about. So what do we get first?
4.
Mm-hmm.
And then 6x. Or minus 6x.
Minus 6x. Yeah.
Plus 9x squared.
Plus 9x squared. Yeah. So 2 times 2, and then a minus 2 times 3x, and then a plus 3x times 3x. The one in part B, I really like that problem. Because there's sort of 2 ways we could start out that factoring process. And one of them is much easier to see to get it to factor all the way. We could see this as a difference of squares, because x cubed is the square, x to the 6 is the square of x cubed, and 64 is 8 squared. We could totally do that. And then we get one of those to like factor a little further. And in fact, let's do it. I'm going to do that up here. So this is x cubed squared minus 8 squared. So it would be x cubed. Oh wait, hold on. That is the right way. That is the better way. So I want to give myself lots of space to do that down here. So, yeah, x cubed squared minus 8 squared, right? And then this is, we could factor this difference of squares. So we get x cubed minus 8, x cubed plus 8. Does that look right? Now both of those will factor. We have a difference of cubes and a sum of cubes. So with the x cubed minus 8, we'll have x minus 2 times x squared plus 2x plus 4. And with the x cubed plus 8, we have x plus 2 times x squared minus 2x plus 4. So that's as far as it will factor completely. If, on the other hand, I viewed that as a difference of cubes first, because it is, x to the 6 is the cube of x squared, and 64 is the cube of 4. So we'd have x squared minus 4 times x squared is x to the 4th, plus 4 times x squared is 4x squared, and then plus 4 times 4 is 16. Here we could see that this x squared minus 4 will factor to x plus 2x minus 2. Now, I don't know about you, but I look at that x to the fourth plus 4x squared plus 16. It's really hard to see how that will factor. It doesn't unfoil, right? I mean, I could imagine trying to unfoil it, right, with an x squared and x squared and some other, like some constant. But we started with the same expression. We know that x to the 6 minus 64 is equal to this thing we got on the bottom first. We also know that it's equal to this expression that we got when we first saw it as a difference of cubes. We can see two of these things lining up nicely, or sorry, I guess three of these factors. There's our x plus 2x minus 2. There's our x plus 2x minus 2. What is not at all obvious is that x to the fourth plus 4x squared plus 16 must factor as the product of these two like trinomials, which is kind of cool when you think about it, but it was so much easier to get the full factorization when we treat it as a difference of squares first than when we treat it as a difference of cubes first. Fun? Because it's the first day of class, so you have to bring more energy. It's too early in the semester to be tired.
It's too early in the morning to be awake. I'm used to having this class at like 2:30.
Yeah, that's true. You need more coffee in the morning. All right, so now that we've reviewed some factoring, we know that being able to factor is super useful because it helps us simplify fractions. If we're going to simplify a fraction, it always starts with factoring. Let's factor the top, factor the bottom. How does the top factor?
X plus 2, x minus 4.
X plus 2, x minus 4. Good.
And then x plus 4, x minus 4 on the bottom.
Close. It's a 4 squared minus x squared, so I think we got to reverse them. So 4 plus x, 4 minus x. Now, 4 plus x is the same as x plus 4, right? The order of addition doesn't matter, but the order of subtraction does matter. So we factor first and then try to cancel common factors. Do we have a common factor? Who remembers how this goes? Yeah, like, so this guy right here, if I want to reverse the order of subtraction, and I think I do because, we have that x minus 4 up top, we can do that as long as we take out a negative 1. I'm just going to write that as x plus 4 because I like starting with the x. And then it's a minus 1 times x minus 4. And now we can cancel. It's kind of cumbersome to put a negative 1 factor in the bottom, I think. So I usually write it on the outside. It's okay to leave it on the bottom, but this is why I'm putting it on the outside. Or sometimes I just attach it to the top. I'm going to skip the next one. I'm going to come back to the next one, but because it's already come up, this will be what I do in my next revision, I think. These factors that differ only in sign. That's what we just used that fact, right? So I'm going to do this one first, and we'll go back to the last one, just to kind of stay on that theme. So the top can factor. That's a difference of squares, x plus 1, x minus 1. And then, of course, down here we have a 1 minus x. We're going to take out that negative 1 so that we can factor. So that we can cancel those common factors. And then the result is x plus 1 over negative 1, which is a negative x plus 1. You could leave it like that or distribute. Negative x minus 1. Either is okay. Now let's go ahead and go back up to this last one. What do we do? I drew the fraction bar already, so I got that step done.
So I know it's wrong, but my head wants to take out a cube, which is stupid, obviously.
Take out a cube.
From the top.
Hmm.
Because 8 cubes down. Cube roots to 2, but it's negative 8.
So you're saying that y cubed and 8 are both cubes?
Yeah, so we could take out something. 'Cause
Yeah. What can we do?
Different.
It's a difference of cubes.
Or that works too.
Yeah. I mean, noticing that they're both cubes is like, right? That's what gets us to being able to do this. So how does that factor?
Oh, y minus 2.
Y minus 2.
And y squared. Plus 2y.
Mm-hmm.
And plus 4.
Yeah. I'm not going to try to factor the bottom. It doesn't factor. You could try. It doesn't factor, but I don't care because that's my common factor. So we just get y minus 2. Do you have a question?
Did you mean for that to work out like that?
Did I mean for that to work out? Like, so that we get that same factor?
Mm-hmm.
Yeah. I chose that example specifically for that reason. What's kind of, so I guess just one kind of takeaway from this, we're taking a very kind of mechanical algebraic approach, right? Which is kind of how we work it out. But just to give some context, if I don't have it with me, but like if I had my graphing calculator, we could put this function in to my y1. And in fact, actually, I do have a graphing calculator. If you just look at that as an expression, it seems like looking at it like it might be all curved and have weird behavior, right? I've got a cube upstairs, I got this quadratic on the bottom. Hold on. So let's see, we put that in, I got to put it in as x's. So on the top, I've got x cubed minus 8. On the bottom, I have x squared plus 2x plus 4. So when we just look at that as an expression, it's hard to see exactly what its graph would look like, but I wouldn't be surprised just because of what it looks like that it might be all curvy and have like an asymptote or something. But if I look at this, it's a line. In fact, it's the line x minus y equals x minus 2. We could see algebraically that it's equivalent to that linear. And then we can also see it graphically. We just put it in the calculator. Fun? Okay. Let's do a little more. Doing some arithmetic with the fractions, or I guess it's algebra since it's not just numbers, but the multiplying and dividing is a little easier than the adding and subtracting. With multiplying and dividing, we always start by factoring, right? So we're going to factor everything. When we multiply, we just multiply straight across, right? So we factor everything, look for stuff that'll cancel. Anything on the top, cancel the common factor on the bottom. When we're dividing, it's really the same thing, but we just first have to write it as a product, right? Like dividing by fractions, same as multiplying by the reciprocal. So how do I start this example?
Do you distribute the second or the
Well, so if I multiply things out, I'm making my job harder. Because the first thing we always do is factor everything. We factor everything as far as it'll go. So the x squared minus 4x plus 4 How does that factor?
X minus 2,
X minus 2, X minus 2. Okay, how about on the bottom?
X plus 3, X minus 2.
In the next fraction? Take out an x, yeah. X plus 3, good. And then on the bottom? X minus 1, yeah, good. So now that we factored, we just, see what will cancel. Anything on top can cancel with on anything on the bottom that's the same factor. They don't have to be already a part of the same fraction. So the x plus 3 cancels with that x plus 3.
X is cancelled.
The x's cancel and?
X minus 2.
And I think that might be it. So we have x minus 2 over x minus 1. Can we cancel those x's? No? Why? They're terms, they're not factors. Good. Let's do another. How do we start? 2 times x minus 2. Yeah, we're going to factor everything we can. How about the bottom?
4x plus 3.
And the other fraction?
So 2x plus 5. X minus 3.
Let's see. So the 2x squared and the minus 15 work out. Plus 5 minus 6. Yeah. Oh, I don't think we're going to swap the numbers. I think we're just going to swap the signs. Like that. And then 3x minus 1 doesn't factor. Now what can we do?
You get rid of x plus 3.
Get rid of the x plus 3. Yeah, 2 goes into 4 twice. And I think that's it. So we just have x minus 2, 2x minus 5. On top, on the bottom, we have 2, parentheses, 3x minus 1. I always leave things factored if I'm doing multiplication division. If you want, you could, multiply it out, but usually that doesn't get us anything, and it's just an extra step. Okay, let's do some division. The first thing we got to do is write it as a multiplication. So the first fraction stays as is, x plus y divided by 3, and then we're going to multiply by, I'm going to flip the second one over, 6x plus 15y over 2x plus 2y. Now we go through and just do it like we did the last ones. In the first fraction, nothing factors, so that stays, and then we just want to factor the second fraction. What is the top factor is?
3, 2x plus 5, or plus 5y.
How about the bottom?
3x plus 1.
Yeah. And now what? The 3's cancel?
That's fine.
Yeah. So we have 2x plus 5y over 2. Do those 2's cancel? No. 2 is a factor of this particular term, but it's not a factor of the whole numerator. It's not like two parentheses stuff. So that stays. Ready for more? Yeah? Pretty ready? We're dividing some fractions, so we'll start out the same way. Let's rewrite it as a multiplication problem. So the top fraction stays the same. And then we're going to multiply by the reciprocal of the bottom fraction. So 2x squared plus x minus 6 over 2x squared minus x minus 15. Can we just cancel those 2x squareds? Oh. I'm glad we've got to a point where even when I ask that question, you're like, of course we can. Good. That's a beautiful thing. Don't ever lose that. Let's factor some stuff. Let's do the first fraction. Say that again. Well, let's see. We have to try to factor it first. X plus 3, x minus 3. How about the bottom? Two x plus 3, 2x minus 3. Still a difference of squares, but 4x squared is just the square of 2x. Next fraction. What goes on up top? Two x plus 3, x minus 2. So that's a plus 3x and a minus 4x. I think we gotta swap the signs, yeah. Okay. You got the numbers in the right locations, though. That's good. What about on the bottom? X plus 5, x minus 3. So that's minus 6 plus 5. That works. Okay. All right, now what?
X minus 3, x minus 3.
Mm-hmm.
2x minus 3, x minus 6.
Yep. Anything else? I think that's it, yeah. So we have x plus 3, x plus 2, 2x plus 3, 2x plus 5. Cool. Pretty nice. Questions? Okay. So this is a light day. That's it. That's all I wanted to do today. We're going to finish this chapter on Thursday. We're going to do some adding and subtracting fractions and then equations with fractions. Let me know if you have questions. Does everybody have the book or access to it?
It was the same as last semester.
Same as last semester.
Yeah, I have the digital.
What's that?